In part 4 of our lesson on using the trig function definitions, we're going to derive the Pythagorean identities. We'll start with an angle in standard position. We know by definition that r is equal to the square root of x squared plus y squared. Now, if we go ahead and square both sides of this, we'll get r squared is equal to x squared plus y squared. And we're going to consider these three cases. So first, I'm going to take this and just write it in the reverse order, where I have the x squared plus y squared first, and then equals r squared. Now, we're going to be dividing the whole thing by r squared, meaning both sides have to get divided by r squared. So, divide by r squared, divide by r squared, and we've got x squared over r squared plus y squared over r squared is equal to 1. Now, when the exponent is the same, we can write this as x over r quantity squared. We can write this as y over r quantity squared is equal to 1. And we know that x over r is just cosine theta squared. Y over r is just sine of theta squared equals 1. And if you recall from a previous lesson, we can use shorthand to write this as cosine squared of theta plus sine squared of theta equals 1. And this is the first of the Pythagorean identities. Next, we'll start from that same equation, x squared plus y squared is equal to r squared, but this time we're going to be dividing both sides by x squared. So divide the left-hand side by x squared, divide the right-hand side by x squared. So now we're going to get x squared over x squared plus y squared over x squared is equal to r squared over x squared. Now we know x squared over x squared is going to be 1. We can rewrite this as y over x quantity squared, and we can rewrite this as r over x quantity squared. And we see we're going to end up with 1 plus y over x is tangent of theta quantity squared. R over x is secant theta. That quantity is being squared. So we can write that as 1 plus tangent squared of theta is equal to secant squared of theta. And that is the second of the Pythagorean identities. To find the last one, we're going to start again from that same equation, x squared plus y squared is equal to r squared. This time we'll be dividing both sides by y squared. So then this will become x squared over y squared plus y squared over y squared is equal to r squared over y squared. We can write this first one as the quantity x over y squared plus y squared over y squared reduces to 1, and this becomes the quantity r over y squared. We know using our trig definitions that x over y is equal to cotangent of theta, and that's being squared, plus 1. R over y, using our trig definitions, is cosecant theta, and that's being squared. So finally, we can write this as cotangent squared theta plus 1 is equal to cosecant squared theta. And that is our third and final Pythagorean identity. Now we will use these throughout the semester, so you're going to want to memorize these right away as soon as possible. And one of the ways I recommend memorizing all these identities we're having to learn is to write them down every day. Write them all down a couple times in the morning, write them all down a couple times in the evening, and before you know it, you'll have them memorized. We'll go ahead and make a box here to summarize the Pythagorean identities we just learned. That cosine squared of theta plus sine squared of theta is equal to 1. We learned that 1 plus tangent squared of theta is equal to secant squared of theta. And finally, we learned that cotangent squared of theta plus 1 is equal to cosecant squared of theta. Now, in this example, we're given that secant of theta is 7 over 2, and that theta lives between 270 degrees and 360 degrees, which we know means theta is in quadrant 4. And we're being asked to find the tangent of theta using an identity. Now we know that the identity that involves secant of theta and tangent of theta is that 1 plus tangent squared theta is equal to secant squared theta. Now we can sub in the value that we know, which is that secant is 7 over 2, and we're going to be squaring that. The left-hand side stays the same, 1 plus tangent squared theta. We know that 7 over 2 squared is going to be 49 over 4, and so I'm probably going to want to think of 1 as 4 over 4 plus tangent squared theta. Now we can subtract 4 over 4 from 49 over 4 to get 45 over 4 on the right hand side. The left hand side is tangent squared theta, and now we're going to make use of the square roots property, which says then that tangent of theta is going to be plus or minus the square root of 45 over 4. Now let's start simplifying this. We can determine the positive or negative sign of this value based on the quadrant that theta lives in. And we noticed earlier that theta is in quadrant 4, and we know that in quadrant 4 the tangent has to be negative. So moving forward here, we're going to keep the negative. Now the denominator is the square root of 4, which is 2. The numerator is the square root of 45. Now we know 45 has a perfect square of 9 in it, so that's radical 9 times radical 5. And so we're going to end up with negative 3 radical 5 over 2. A great way to memorize these identities is to write them down several times every day. You will use them all throughout trigonometry as well as in calculus.